Hi, today topic is once again functions. It is the continuation of earlier two videos. If f is a relation from set A to set B, then how many relations can exist from A to B? Instead of writing f, we can write R. If R is a relation from set A to set B, then the number of relations from set A to set B is taken as 2 to the power of n of A into n of B. So total number of relations from set A to set B is 2 to the power of n of A into n of B. Remember this formula, total number of relations. If f is a function from set A to set B, then how many functions can exist from A to B? It is number of elements in B to the power of number of elements in A. So total number of functions from set A to set B are n of B power n of A. Remember, number of elements in the codomain to the power of number of elements in the domain. This is the total number of functions from set A to set B. Then from A to B, how many relations can exist which are not functions? So total number of relations is 2 to the power of n of A into n of B minus total number of functions is n of B to the power of n of A. So total relations minus total functions. From total relations, if you subtract total number of functions, the remaining are only relations but not functions. Therefore, number of relations which are not functions is given by this one. So, total number of relations is 2 to the power of n of A into n of B. Total number of functions is n of B to the power of n of A. Number of relations which are not functions is total relations minus total functions will give you that one. Now, how many 1-1 functions can exist from set A to set B? Number of 1-1 functions from set A to set B. Now, you know NPR notation. Number of permutations of n things taken R at a time. This notation we will use for finding number of 1-1 function. Total number of 1-1 functions from set A to set B can be taken as n of BP n of A. n of BP n of A. You know NPR is defined only when R is less than or equal to n. So number of 1-1 functions will be defined only when n of A is less than or equal to n of B. n of A must be either less than n of B or equal to n of B. Otherwise, NPR will not exist. Therefore, number of 1-1 functions from set A to set B is n of BP n of A if n of A is less than n of B. If n of A and n of B are equal, then it will become NPR will become NPN, which you know is n factorial. Therefore, when n of A and n of B are equal, n of A n of B are equal, this will become n of A factorial or n of B factorial. So, when n of A and n of B are equal, number of 1-1 functions is n of A factorial. When n of A is less than n of B, number of 1-1 functions is n of BP n of A. If n of A is greater than n of B, if n of A is greater than n of B, then 1-1 functions cannot exist from A to B. This is summarized here as When n of a is less than n of b, number of one functions is n of b p n of a. When of a and n of b are equal, number of one functions is n of a factorial. When n of a is greater than n of b, number of one functions is 0. That means one functions do not exist. Then we go to number of onto functions. If n of a is greater than n of b, if n of a is greater than n of b, suppose n of a is r and n of b is n, then when r is greater than n, only then number of onto functions can exist. So number of onto functions will exist only when number of elements in A is greater than the number of elements in B. The formula for finding number of onto functions when r is greater than n is n to the power of r minus nc1 n minus 1 to the power of r plus nc2 n minus 2 to the power of r and so on, plus minus plus minus, it goes alternately like that. N power r, n minus 1 power r, n minus 2 power r, it goes like that. Then nc0, nc1, nc2. This is the formula for finding number of onto functions when n of a is greater than n of b. When n of a and n of b are equal, when n of a and n of b are equal, number of onto functions is n of a factorial only. But when n of a is less than n of b, when n of a is less than n of b, then number of onto functions is not defined. This is summarized here. Number of onto functions equal to this formula if n of a is greater than n of b. Number of onto functions is n of a factorial if n of a and n of b are equal. Number of onto functions is 0 if n of a is less than n of b. But when the codomain contains only 2 elements and the domain contains greater than or equal to 2 elements, number of onto functions can be taken as 2 to the power of n of a minus 2. This is about onto functions. Then number of bijections. Number of bijections only will exist when n of a equal to n of b. When n of a and n of b are equal, number of bijections equal to n of a factorial. Then constant function is a bijection only when number of elements in the domain, number of elements in the codomain is equal to 1. Only when there is one element in the domain and one element in the codomain, bijection, a constant function will become a bijection. There are more elements in the domain, the constant function cannot be a bijection. So remember, a constant function is a direct bijection only when both the domain and the codomain contain exactly one element. This is the discussion about number of functions. A function which is not 1 is many 1. A function which is not onto is into. Any function which is not 1 is called many 1. Any function which is not onto is called into. Not onto is into. Not 1 is many 1. So to find out the many 1 functions, find out the total functions and then subtract 1 function. So a function which is not 1 is many 1. To get to many 1 functions, from total functions subtract 1 functions, you will get many 1 function. Similarly, from total functions, if you subtract number of onto functions, you will get the remaining functions as into functions. This is the way to find out the number of many 1 functions and the number of into functions. Yes, now we discuss about functional equations. First one is f of x plus y is equal to f of x into f of y. Sum of x and y here f of x into f of y. If this condition is satisfied by any function, then the function should be of the form f of x equal to k power x. F of x equal to k power x with one condition. We have to find out this k value which will be given in the question. So remember, if f of x plus y equal to f of x into f of y, then the function should be of the form k to the power of x. If f of x plus y is equal to f of x plus f of y, function value at x plus y is equal to value of the function at x plus value of the function at y. If this condition is satisfied, then the function will be of the form f of x equal to kx. Here k is a constant. Then if f of xy is equal to f of x plus f of y, f of product of x and y is f of x plus f of y, then f of x will be of the form k times log x base a. You know, log of mn is equal to log m plus log n. So mn like xy, log m plus log n, f of x plus f of y. This type it will come here. So whenever f of xy is equal to f of x plus f of y, you can take the function as k times log x base a. Now the next one is very important one which will be used in many problems. F of x plus f of 1 by x, x and the reciprocal of x. F of x plus f of 1 by x is equal to f of x into f of 1 by x. The sum of these two numbers, is equal to product of these two numbers. If this condition is satisfied by any function, then the function should be of this form 1 plus or minus x power n. The function will be either of the form 1 plus x power n or of the form 1 minus x power n. Which one to be chosen among these two, out of these two, that depends upon the given condition in the problem. And the last one is, if f of x plus y and f of x minus y are added together, if f of x plus y plus f of x minus y is given as sum, then it will be equal to 2 times f of x into f of y. Then the function should be of the form cos x. For example, if x is a, y is b, then function is f of x equal to cos x, and f of a plus b, or f of x plus y, f of a plus b is equal to cos of a plus b, and f of x is cos a, f of y is, or f of b is cos b. Then this will become cos of a plus b plus cos of a minus b. This will be 2 times cos a cos b, 2 times cos a cos b. So it is 2 times f of x into f of y. So whenever the function is of the form f of x plus y plus f of x minus y equal to 2 times f of x into f of y, take that function as f of x equal to cos x. That's all.